Hey, today I want to talk about the review for chapter 6 today. So I can show my slides first, and I want to turn off my video. Could you see my review slide? Please write yes if you see the, yep. Okay, thank you, guys. So okay, today I want to talk about the review for chapter 6, the Math 141. So we start. This is my outline. This is like a first example. So we think about section 6.1, the inverse function. This is the first question. Find the inverse function of f of x equals ln of 2x minus 3 minus ln of x plus 1. So how can you find the inverse function? I want to use algebraic method for solving this problem. We follow 3 steps. I can show to you here. Step 1, you need to write y equals f of x. So you can write y equals ln of 2x minus 3 minus ln of x plus 1. The next, you need to combine this 2 ln to only 1 ln. How can you combine? Like this. Here, remember this one? We have logarithm laws, the natural logarithm laws. The first law is the ln x plus ln of y. We have ln of x times y. This is the first rule. The second rule is the ln x minus ln of y is ln of x over y. The third rule is the r times ln of x equals ln of x to the power r. So we have 3 important rules. You need to memorize these 3 rules. So how can you use this rule? We can use the second one. Difference is going to fraction. So change it like this. This is step 1. Step 2, solve this equation y equals ln of 2x minus 3 over x plus 1 for x in terms of y. So how can you do that? How can you eliminate ln? So my part is, how can you eliminate ln? Do you have any idea? How can you eliminate ln? Do you know? Some idea for eliminate ln? How can you eliminate ln from this form? Yeah, it's a good idea. You can take e, you're right. So we can take e, the both sides. So automatically the e ln cancelled. We can use cancellation equation. So we have e to the y equals 2x minus 1 over x plus 1. The next, you multiply the both sides by the denominator x plus 1. The next, you have to distribute. You have to distribute e to the y to x and 1. Distribute. Next, x plus 1 is crossed out. So we have this one. So like this. The next, you have to isolate x terms on one side. We have 2x terms, x e to the y and 2x. So I want to move x e to the y to the other side. You subtract x, here, erase. So like this. You subtract x e to the y from both sides. So like this, what happens? X to e to the y is cancelled. The next, you add 3 to both sides. You have to eliminate 3, you have to move 3 to the other side. So what happens? We have this one, so like this. The next, the right hand side has common factor x. You factor out x. The next one, you have to divide the both sides by 2 minus e to the y. So you have to divide the both sides by 2 minus e to the y. You can divide the both sides. 2 minus e to the y. Like this. So we have this one. It's like a step 2. What's it like step 3? Step 3 is interchange x and y. So what does it mean? So like this. You have to interchange x and y. You can replace x by y by x. That's it. This is like step 3. This one. Step 3. The resulting equation is inverse function. That's it. This is the whole idea for solving the first kind of problem. Second one. The derivative of the inverse function. So f of x is given 10 over pi x plus sine of x plus cosine of x. Find inverse of f prime of 6. So how can you solve this problem? The idea is like this. Do you know the theorem? The function, right here is better, like this. The function f is 1 to 1. So what happens? We have this result. Inverse function prime of a is 1 over f prime of f inverse of a. So this is like the main idea for solving this problem. So first, you can check. Function f is 1 to 1. So what do you think? Function f of x is 1 to 1. Is it right? What do you think? So f is 1 to 1 or not? So could you write your answer? What do you think? The Calvin said yes. Yeah, he said yes. Okay, so 2 guys said yes. You're right. How can you know that? The calculate f prime. F prime of x is 10 over pi x plus sine x plus cosine of x prime. So we have 10 over pi x plus sine x plus cosine x prime. So what's that? Exactly 10 over pi x prime is only 10 over pi. Sine prime is cosine. The cosine prime is negative sine, right? So what happens? So what's it like pi? Pi is approximately 3.1 something like that. So what is 10 over pi? The 10 over pi is, I don't know exact number, like 3 point something. is like 10 over pi. What's the maximum value of cosine? Maximum value of cosine is 1. The maximum value of sine function is 1. What's the minimum value? Minimum value is minus 1. Minimum value is minus 1. So what does it mean? You just only add 10 over pi to the minus 1 and minus 1, like a smallest number. What happens? 3 minus 1 is positive 1. So this is always positive. This is like idea. We have it like this. Function f is increasing on level infinity to infinity, automatically 1 to 1. So we can use this result. Inverse f prime of 6 equals 1 over f prime of inverse of f of 6. Step 1, find inverse f of 6. I'm going to write unknown value x. You can use definition of inverse function. This is exactly same to 6 equals f of x. The f of x is here. What's it like f of x? F of x is 10 over pi x plus sine x plus cosine x. You can plug into f of x that we have. So what is x? What is x? Could you write your answer on the chatting board? So what do you think? What is x? So which number satisfies 6 equals 10 over pi x plus sine of x plus cosine of x? How can you find? Just a guess. You can plug a number, so this equation is right or not. You can think about it. Pi over 2, pi over 2, pi over 2. You're right. Yes, x equals pi over 2. How can you know that? You plug x equals pi over 2 into x. You can check this equation is right or not. 6 equals 10 over pi times pi over 2 plus sine of pi over 2 plus cosine of pi over 2. So this is exactly same to left hand side is 6. The 10 and 2, what happens? 2 is crossed out, change 5. Pi is crossed out, just 5. Plus sine pi over 2 is 1. Cosine pi over 2 is like 0. So we have 6 equals 6. You're right. The answer is pi over 2. You can check like this way. Next to step 2. What's step 2? Step 2 is here. Now let me see. The x equals pi over 2. What does it mean? In this case, inverse f of 6 equals this x value is pi over 2. You plug into here. So we have 1 over f prime of pi over 2. So what does it mean? You calculate denominator f prime of pi over 2 next. You can find. Plug pi over 2 into here. You can plug this pi over 2 into x. Plug into here. So we have this one. The 10 over pi plus cosine pi over 2 is 0. Sine pi over 2 is 1. So we have 10 over pi minus 1. The same to 10 minus pi over pi. This is step 3. So what's it like step 4? Step 3 is you can plug this value 10 minus pi over pi into denominator. You plug into here. This is like step 3. So step 3 is like this. You can plug. The reciprocal is pi over 10 minus pi. That's it. This is our idea for solving this problem. The next problem here, the limit problem. Find limit ln of x squared minus 25 x minus 5 from the right. So second problem is limit ln of 5 plus x minus ln of 2 plus 3x as x value approaches infinity. So we think about, we try to solve this problem together. So what's like the best way? I want to use graph of ln function. This is like a graph of ln function. So we can use step by step. So x value approaches 5 from the right. What happens? Inner function of ln x squared minus 25. So what's the answer? So what is the answer? So what's that? X value approaches 5 from the right. What happens? X squared minus 25. So what is your answer? 0 from the right. So what do you think, other guys? You have the same answers? Yeah, you can plug 5 into here exactly. 5 squared minus 25 equals 0. Yeah, 0 from the right. Yes, 0 from the right. So we have it. What happens? ln function. What's ln? ln is going to, so what is the answer? Minus infinity. So why? Because x squared minus 25 approaches 0 from the right. Exactly. This inner function is log of x-axis. This log of x-axis is x squared minus 25. The inner function approaches 0. What happens at ln function? Going down to negative infinity. This is down to negative infinity. Answer is negative infinity. Yeah, this is like a whole idea that we have it. So we have this answer. Second one. How can you solve the second one? You can combine ln of 5 plus x minus ln of 2 plus 3x to only one ln. Next, divide top and bottom by highest power in the denominator. The highest power in the denominator is x. So you can divide top and bottom by x. You can distribute 1 of x to the 5 and x, the bottom 1 of x to the 2 and 3x. We have 5 of x plus 1 over 2 of x plus 3. X value approaches infinity. What happens? 5 minus 5 of x. This value is going to 0. 2 of x is going to 0. Answer is ln of 1 over 3. So that's it. This is answer. The next example. Here. How can you solve limit of e to the x minus 6, e to the x minus 5? What's the limit? Arctangent of negative e to the x as x value approaches infinity. So first problem, I want to use exponential function. So same, you can use step by step. X value approaches 5 from the right. What happens exponent? X minus 6 over x minus 5. What is the answer? What do you think? What is the answer? So what is the answer? Infinity? Positive infinity? Is right? Kelvin said the positive infinity. Do you have another idea? The positive infinity is right? So what do you think? Positive infinity? 1 minus 1 over 0. Yeah, minus 1 over 0. You're right. This is undefined. Minus 1 over 0 is undefined. What happens? Minus infinity? Negative something? The minus infinity is the right answer. The why? Like this. So you can plug 5 into x here. What happens? 5 minus 6 over 5 minus 5. It's right. Minus 1 over 0. Undefined. What is it like minus 1 over 0 form? We have two possible answers. So in this case, two possible answers, infinity or negative infinity. How can decide positive infinity, negative infinity? I want to use one-sided limit. X value approaches 5 from the right. So what does it mean? So here, this is 5. X value approaches 5 from the right. I'm going to choose a test number. This test number is close to 5 and greater than 5. I can choose 5.1. You plug into x, plug into here, 5.1, 5.1. 5.1 minus 6 is negative. 5.1 minus 5 is positive. We have negative over positive. What does it mean? Negative infinity. So that's it. This is the whole idea. So this value approaches minus infinity. Why is it like an exponential function? This is exponent x minus 6 of x minus 5 approach minus infinity here. Exponent approaches minus infinity. What happens? Exponential function approach to x-axis. The y value is 0. So answer is 0. This is the idea. Second one, I want to use arctangent. So we can use step by step. X value approaching infinity. What happens? E to the x going to positive infinity here. X value approaches positive infinity. Exponential function is going up, going to the positive infinity. So we have this answer. What's minus x e to the x? Negative infinity. So next, we can take arctangent. What is the answer? So could you write new answer on the chatting board? What is arctangent of minus e to the x? So what is the answer? The negative 5, 2 from the Jesse. So do you have another idea? What you have same answer? Yeah, minus 5, 2 odalis. So it's good. 5, 2 odalis. Thank you, all of you guys. Your answer is right. Here, the minus e to the x approaches minus infinity. What does it mean? This is load of x-axis approaches negative infinity. Was it like arctangent? Arctangent approaches to this dotted line, horizontal asymptote, minus 5, 2. Answer is minus 5, 2. This is the whole idea for solving this problem. So that's it. This is like exactly limit problems. The next tip. So we think about cancellation equation together. Inverse cosine, cosine x equals x for all x in the domain 0 pi. This is important thing. What do you think? Is it right? This is right? What do you think? This is right? Yes? Yes, because was it like a pi over 4? Pi over 4 is between 0 and pi. Yes, in the domain, you have to cancel it. Yes, this is true. What's the second one? This is right? Is this right? No. Why not? Because 5 pi over 4 is So like this, what does it mean? Not in the domain. The 5 pi not in the domain, don't cancel. So this is wrong. How can you solve? You have to move 5 pi 4 to the domain 0 pi. So how can change? Do you know this one? Cosine 5 pi 4 equals cosine 3 pi 4. So what do you think? This is right? Is it right? So how can you know these kind of things? So we can use this idea. So do you know this one? Here we have unit circle. So what is unit circle? The radius is 1. It's like unit circle is given. So I want to find cosine and sine and tangent. This is angle theta. So this point is, this is x component, this is y component. You have to write x and y. What is x? X is exactly same to cosine theta in unit circle. Y is sine theta. What is tangent theta? Tangent theta is y over x is tangent theta. This is like a definition. This is the definition. I can use it. So what does it mean? So here, so we have unit circle. We have unit circle is given. Unit circle. So this angle is 0. This angle is pi over 2. This angle is pi. This angle 3 pi over 2. The angle 0 is the same to 2 pi. So we have it. So what happens? 5 pi over 4. So 5 pi over 4 is in the third quadrant, greater than pi, less than 3 pi over 4. So we have here. So this value is like x and y here. This x value is exactly same to what? Cosine 5 pi over 4. So what's that? What's this angle? This angle is 5 pi over 4 minus pi is exactly pi over 4. So you have to reflect this point about x-axis. So what happened this one? The x value doesn't change, y value changes. Right? Y value is, I can write that this is minus y. This is like a positive y. This x value doesn't change. This is exactly same to this value. X value doesn't change. You can connect this point to the origin. What is angle? This angle is pi over 4. So what's like original angle? Original angle is pi minus pi over 4 is 3 pi over 4. So we have this answer. This is the whole idea. So next to take inverse cosine, you have to cancel. We have it. So one more. So you need to know two more things. What is inverse sine of x equals x for all x in this domain. Negative pi over 2 and pi over 2. So we have it. What is inverse tangent of x equals x for all x in open interval negative pi over 2 and pi over 2. So this equation, we have inverse sine of pi over 7 equals pi over 7. This is right? This is right. So what do you think? Yeah. Yeah, two guys said yes. You're right, because pi of 7 is in the domain. In the domain, yes, cancelled. True. What is inverse sine of sine 9 pi over 7 equals 9 pi over 7? What do you think? This is true or not? Yeah, this is no. Don't do that because not in the domain. It's a good answer. The good answer. Yeah, not in the domain. Not in the domain. This is the reason. Okay, this is like this kind of problem. The next one. So we think about exact value of secant arcsine 4/5. How can you find this kind of problems? So step one, you have to write arcsine of 4/5 like arcsine of 4/5 we don't know is right theta. This is step one. The next thing, the arcsine is inverse sine. I want to use definition. It's the same too. 4/5 equals sine theta. Sine theta. The next thing, you can draw right triangle theta. Sine theta is, yeah, I think you're right, 5/3, you're right, I think. So this is like opposite over hypotenuse. So we don't know adjacent, you can write y. You can use a Pythagorean theorem, y squared plus the 4 squared equals 5 squared. This is same to the y squared plus 4 squared plus 16 equals 25. You subtract 16 from both sides, so we have this result. Y squared equals 9. Take square root, y equals only positive 3. So we have it. This y equals positive 3. You can plug this theta into here. You plug into here. So what happens? The secant arcsine of 4/5 is exactly same to the secant of theta. What is secant of theta? 1 over cosine theta. The 1 over cosine theta is adjacent over hypotenuse. Adjacent over hypotenuse. Just to flip 5/3. Yep, you're right. The 5/3. This is the whole idea for solving this problem. So like this. The next one. Inverse cosine x of 3. How can you solve? Same idea. Inverse cosine of x of 3 equals unknown theta. You can use definition. Cosine theta equals x of 3. You can draw right triangle. Cosine theta is adjacent over hypotenuse x of 3. The opposite is unknown. You can write y. How can you find y? We can use Pythagorean theorem. You subtract x squared from both sides. So we have it. You subtract x squared from both sides. We have this one. Next is square root. Y equals square root of 9 minus x squared. So, what's that? This y is same to square root of 9 minus x squared. We are going to original problem. This original one is same to inverse cosine of x over 3 is theta. You plug exactly tangent theta. What's tangent theta? opposite over adjacent. The opposite y is here, square root of 9 minus x squared, square root of 9 minus x squared over x. That's it. This is the whole idea for solving this problem. The next one, you have to memorize these differentiation formulas. Do you know what is C prime? Could you write your answer on chatting board? What is C prime? The C is constant. What is constant prime? Okay, thank you, all guys. Yazira. What's X prime? Okay, good. So what is X to N prime? Do you know X to the N prime? X to the N, X to N minus 1, yeah. So you need times N. So N times X to the N minus 1. So what is CF prime? C times just the function prime. F plus or minus G prime is F prime plus or minus G prime. F times G prime is, we use product rule. F prime G plus F times G prime. F over G prime is quotient rule. top on prime times bottom on minus top on times bottom on prime over bottom on squared. What's the sine prime? Do you know sine prime? Yeah, thanks. Cosine. What's the cosine prime? Yeah, thanks. Never sine. What's the tangent prime? Equals secant square. Yeah, thanks. Yeah, guys. Yeah, secant square. Cotangent x prime is, do you know cotangent x prime? Do you know? Yes, negative cosecant squared. What is secant prime? Yes, secant tangent. What is cosecant prime? Negative cosecant cotangent, you're right. Negative cosecant cotangent, you're right, yes. So do you know chain rule? F of g of x prime is outer function prime of inner function times inner function prime. What's the power rule combined with the chain rule? G of x to the power n prime is n times g of x to the n minus 1 times g prime of x. So we have more things. What's the ln of x prime? Okay, thank you, guys. 1 over x. Do you know ln of g of x prime? So what is the ln of g of x prime? So do you have any idea? ln of g of x prime? Yeah, Alice, Jess, Odalis, Min. Yep. G prime of x over g of x, you're right. The log x with base a prime, I want to use the change of base. You can change ln of x over ln of a. So take out ln of a, only ln of x prime. In this case, you just only use this one. So take out constant ln of a, just ln of x prime. Same to 1 of ln of a times x prime is x. We have x times ln of a. So that's it. This is the whole idea. So e to the x prime is e to the x. E to the g of x prime is e to the g of x times g prime. A to the x prime is a to the x times ln a. A to the g of x prime is a to the g of x times ln of a times the power prime g prime of x. Inverse sine prime is 1 over the square root of 1 minus x squared. Inverse cosine prime is minus 1 over square root of 1 minus x squared. Inverse tangent prime is 1 over 1 plus x squared. Inverse cotangent prime is minus 1 over 1 plus x squared. Inverse secant x prime is 1 over x times square root of x squared minus 1. Inverse cosecant prime is minus 1 over x times square root of x squared minus 1. So you have to memorize all differentiation formulas. This is very useful. I'm going to give examples here. The first one. The f prime is x times ln of x minus 5x prime. So how can you solve? We can use this idea. Just x times ln of x prime minus 5x prime. Sure, I'm going back to, so here, yep, the education, I going back to slide 9. The last one here, yeah, inverse cosecant x prime is minus 1 over x times the square root of x squared minus 1. That's good. You can find this my lecture note on Canvas. I already upload. This is my lecture note. The review for chapter 6 on Canvas. I think week 4. We are going to week 4 on Canvas. You can find this whole thing is exactly same. I just uploaded this whole kind of things. Okay, going back, so you can use it. So this is the same to product rule. First prime times second one plus first one times second one ln x prime minus 5x prime is just 5. Here x prime is 1, just ln of x plus x times ln of x prime is 1 over x minus 5. X is crossed out, ln of x minus plus 1 minus 5. Final answer is ln of x negative 4. So that's it. This is like the whole idea for solving this problem. So we have it so like this. It's good. ln of sine square x prime. What's like the best way? I suggest that this is like better. Do you know this one? So we have ln function, the sum function to the power r. What's the best way? The take out r times ln of x. So what does it mean? The sine square, this is like down here, 2 times ln sine of x prime, take out 2, just ln sine of x prime. So we have 2 times ln sine of x prime is inner function prime over inner function. So 2 times sine x prime is cosine. Sine x is sine. So do you know identity of cosine of sine? Do you know one identity? Tangent or cotangent? Which one? Yes, cotangent. So we have the 2 times cotangent of x. So you need to know this one. Sine x over cosine of x is tangent. Yes, this is tangent. The one more. The really be careful, this one. What do you think? This is right? No? Yes? What do you think? ln of x to 5 equals 5 times ln x? Yes, it's right. Here, same. Yes. What's that? What do you think? This is right? No, really be careful. So this is not 5 ln. So 5 is power of just x, take out. 5 is power on the ln of x? No, 5 is not in going down. Not 5 times ln of x. So really be careful. So we have it. The next one, this one. How can do that? We think about arctangent prime. What's it like arctangent prime? 1 over, do you know this one? Arctangent x prime is 1 over 1 plus x squared. So you plug e to the 3x into x. So here. Here times inner function prime. This is like an idea. So we have it. The next to simplify. 1 over 1 plus e to the 3x squared is 3x times 2 is 6x. E to the 3x prime is e to the 3x times 3x prime. Now, how can you find this one? We can use previous slide like a formula. E to the g of x prime is e to the g of x times g prime of x. We can use it. This is like g of x is same to 3x. So we have it. That's it. This is the whole idea. The next one. How can you find log arcsine root x with base 3? The best way is we can use change of base. You know this one? You need to know this one. The log x with base a is exactly same to ln of x over ln of a. It's like idea. Always change it like this. ln of arcsine of root x over ln of 3 prime. You can take out constant 1 over ln of 3. The next ln of arcsine of root x prime is arcsine of root x prime over arcsine root x. Was it like arcsine root x prime? Here, arcsine of x prime is 1 over square root of 1 minus x squared. You plug root x into here. So you have to keep 1 over ln 3 times 1 over arcsine root x. You have to keep this one times. Arcsine root x prime is 1 over square root of 1 minus root x squared times inner function prime, like a chain. This is like idea. So we have it. Next, to simplify. Here, the root x squared is this one. The root x prime is 1 over 2 root x. Is right? How can you find this one? X to the 1/2 prime is. You can use power rule. 1 over 2 is down. X to the 1 over 2 minus 1 is 1 over 2. X to the minus 1/2. Same to 1 over 2 times x to the 1/2. Change it back to radical form. So that's it. The combine here. 2 times ln of 3 is here. So this is square root of x is here. The root x squared is 1. Sorry, x. Root 1 minus x. Arcsine root x is here. So that's it. This is the whole idea. The next one. Find the second derivative of g of x 2 times x cubed plus 1. How can you find? I want to use this one. A to the g of x prime. This prime is a to the g of x times ln of a times g prime of x. We can use it. So this is what? 2 to the x cubed plus 1 times ln of 2 times x cubed plus 1 prime. So this is same to 2 to the x cubed plus 1 times ln of 2 times x cubed prime is 3x squared. We have this one, the reorder, 3x squared ln of 2 times 2 to the x cubed plus 1. So we have this one. Oops. Right? The next here. Second derivative, 3 ln of 2 x squared 2 to the x cubed plus 1 prime. Take out 3 times ln of 2, x squared 2 to the x cubed plus 1 prime. You can use product rule. The first function, x squared prime times 2 to the x cubed plus 1 plus x squared times second one, 2 to the x cubed plus 1. So we have this result here. X squared prime is 2x. The 2x cubed plus 1 prime is exactly same to previous result you plug into here. And reorder 3 times ln of 2, 2x cubed plus 1 plus 3 is here. ln of 2 is here. X squared times x squared is x to 4. The remaining part is here. The next one, we think about the logarithmic differentiation. The logarithmic differentiation is used for finding derivative of complicated functions involving products, quotients, or powers, or f of x equals g of x to the h of x. G of x is basis function. H of x is like a powers function. The basis function, powers function, we use logarithmic differentiation. What's that? So this example, f of x equals x plus square 2 to the 4 sine square of x over cube root of x. Exactly product quotient powers. You can use logarithmic differentiation. This is the same. The power quotient product. The x squared plus x is exactly same to g of x to the h of x. We have to use logarithmic differentiation. This is the idea. What's the logarithmic differentiation? We follow 3 steps. Step 1, take natural logarithms of both sides of an equation, y equals f of x, and use the laws of logarithms to simplify. Step 2, differentiate implicitly with respect to x. Step 3, solve the resulting equation for y prime f prime of x. What's it like laws of logarithms? We already know that. The next one, ln of x times y, you have to expand ln of x plus ln of y. You can expand. Ln of x of y, you have to expand ln of x minus ln of y. ln of x to the power r, you can change it to the r times ln of x. So that's it. This is the whole idea of laws of logarithms. I want to give example. Differentiate f of x equals square root of 2x minus 1 over 2x plus 1. I want to use logarithmic differentiation. Take ln for both sides. So what happens? ln of square root of 2x minus 1 over 2x plus 1 is ln of 2x minus 1 over 2x plus 1 to the 1/2. Power 1/2 is down, ln of 2x minus 1 over 2x plus 1. The quotient is changed to difference, 1 over 2 times ln of 2x minus 1 minus ln of 2x plus 1. Step 2, take derivative. ln of f of x equals 1 over 2 times ln of 2x minus 1 minus ln of 2x plus 1 prime. So ln of f of x prime is f prime of x over f of x. 1 over 2 times ln of 2x minus 1 prime is 2x minus 1 prime over 2x minus 1 minus. ln of 2x plus 1 prime is 2x plus 1 prime over 2x plus 1. So exactly 1 over 2 times 2 over 2x minus 1, 2 over 2x plus 1. Step 3, you solve this resulting equation for f prime of x. So what happens? Only multiply. So here, this form is given. Just to solve for f prime of x, you multiply the both sides by f of x. So f of x is cancelled. You can replace. This f of x is square root of 2x minus 1 over 2x plus 1 into here. But that's it. This is f prime of x. So one more. The y equals x squared plus 1 to the power x. So what does it mean? Base is function. Power is function. You have to use logarithmic differentiation. The same idea, logarithmic differentiation. You can use logarithmic differentiation. Step 1, take ln power x is down. Step 2, take derivative. You can use product rule. X prime times ln of x squared plus 1 plus x times ln of x squared plus 1 prime. The simplify, the x prime is 1, is right? This is exactly 1. So only this part. So this one is same to inner function prime over inner function x squared plus 1 prime of x squared plus 1. So was it like this one? X squared plus 1 prime is just 2x and plus. So it's right. This is same to only 2x. X times 2x is 2x squared. We have it. Step 3. What's step 3? You can multiply both sides by y. Y. This is like step 3. So like this. Y is crossed out. Y prime is y times ln of x squared plus 1 plus 2x squared over x squared plus 1. So replace. This y is exactly same to original one, x squared plus 1 to the x, you plug. So that's it. This is the whole idea. The last part is integration. We think about this one. Do you know integral k dx? What is the answer? What is integral k dx? K is constant. K is constant. What is integral k dx? kx, Jesse said kx, Min said only x. What is the answer? Kx plus c. Yes, kx plus c. What is x to the n dx? Like a chain, this is a power rule. 1 over n plus 1, x to the n plus 1 plus c. In this case, n is not equal to minus 1. Do you know integral 1 over x? Do you know what is the answer? Could you run your answer on chatting board? What is the answer? ln of x plus c, ln x plus c, ln x plus c, ln x plus c, absolute value. ln of absolute value of x plus c. Really be careful. Absolute value. This is ln of absolute value of g of x plus c. Does it make sense, this one? But why this is true? I want to use u substitution. G of x is u. the du is, yes, the integral 1 over x dx always use the absolute value. But in this case, I'm going to give one example. Oops. Give one example. This problem, you take out to this one, to add and up, yes, absolute value of x plus c. The next one, 2 is going to power, add and up, absolute x squared plus c. In this case, 2 is like even power, 2 is even power. The absolute value of x squared is always positive. 2 is even power, always positive. In this case, you don't need it. Only this case, so like this. Indefinite integral, we don't have we don't have exception. Trig sub. The trig sub is we don't have absolute value in the trig sub. If you use trigonometric substitution, we don't have absolute value. Yeah, function is always positive. We don't need absolute value sign. You're right. Yes. Okay, here. So I'm going back to this problem again. The du is g prime of x dx. So this is same to integral 1 over u du. You can use this rule and change back at an of absolute value of g of x plus c. Yeah, this is like I. Integral e to the x dx is e to the x plus c. Integral e to the kx dx is, do you know what's e to the kx dx? Do you know this one? What's integral e to the kx dx? Do you know? E to the kx over k plus c means says the other guys agree with mean answer e to the kx over k, k e to the kx plus c. So what do you think? Yes, 1 over k e to the kx, e to the kx over k plus c. So really be careful here. E to the kx prime is e to the kx times inner function kx prime is e to the kx times k, exactly k e to the kx. Yeah. The differentiation k times e to the kx integral the fraction 1 over k e to the kx plus c. Integral a to the x dx is the a to the x over ln of a plus c. Integral sine x dx is negative cosine plus c. Integral cosine is positive sine. Integral secant square is tangent x plus c. Similar. So you need to memorize general form is better. Integral sine kx dx is minus 1 over k cosine kx plus c. integral cosine kx dx is 1 over k sine kx plus c. integral secant square of kx dx is 1 over k tangent kx plus c. How can you find this one? We can use u substitution. U is inner function kx. You can apply u substitution into sine kx, cosine kx, secant square kx. We have these kind of answers. You can memorize. General form is better. So integral cosecant square is negative cotangent. Integral secant tangent is secant. Integral cosecant cotangent is negative cosecant. Do you know integral tangent? What's integral tangent? Do you know? Do you know integral tangent of x? Could you run your answer? What's integral tangent of x? Do you memorize this one? Do you know? What is integral tangent? Yeah, add and secant, same, absolute value. Add and up, absolute value of secant x plus c. So do you know integral cotangent? This is add and up sine x plus c. You don't need memorize. So you don't need it. Don't worry about this one. Integral secant is memorize. Add and up, absolute value of secant x plus tangent. Integral cosecant is add and up absolute value of cosecant cotangent. Similarly, you don't need it. So you don't need in the exam. You don't need it. The next integral 1 over the square root of a squared minus x squared dx is memorized. Inverse sine of x of a plus c. Integral 1 over a squared plus x squared dx is 1 over a times inverse tangent of x of a plus c. So memorize these whole most important integrals before midterm exam. The next one that we think about this problem, how can you solve? The one method is possible. Could you use a formula? Do you know? We learn the 5 method for solving integral problem. First method is important integral formula. Just use formula. Second method is U substitution. The third method is integration by parts. Was it like the first one? The trigonometric substitution. The last one is partial fractions. So we can learn this whole idea tomorrow with Kasha, don't worry. Just in this case, only chapter 6, we can think about basic stuff for integral problems together. So what do you think? How can solve? Integral from 1 to 4, 1 over square root of x times the square root of x plus 1 dx. So what kind of method do you want to use for solving this problem? Integration by parts, U substitution, which one? So let me see. So we have only algebraic function like 1 over root x, 1 over root x plus 1, just an algebraic function. Only algebraic function times algebraic function. Usually we don't use integration by parts. So when do you use integration by parts? Only product of algebraic function and transcendental function. One example is algebraic function x squared times ln function ln of x. We use integration by parts. Or the transcendental function times the transcendental function. The example is the ln of x times sine of x, like this one. So we can use this kind of things. You can use U substitution. You're right. You can use U substitution. And one more rule. What's U? So what is U? So what do you think? What is U? The square root of x plus 1, is it right? Only square root of x or square root of x plus 1? Which one? The square root of x plus 1 or square root of x plus 1? Thank you, guys. Yes, root x plus 1 is U. The TU is, the root x prime is 1 over 2 root x dx. So you can multiply by 2 here. You can multiply by 2. 2 is crossed out. So we have it. The next change. What's that? This one is just U. The 1 over root x dx is 2 du. You plug 2 du. So we have it. Not yet. The split and plug 2u. The one more. You can change one for lower limit, upper limit by using relation of u and root x plus 1. So we have g of 1, g of 4, this one. The next take out 2, what is g of 1? You plug 1 into here. The square root of 1 plus 1 is 2. What is g of 4? You plug 4 into x. The root 4 plus 1 is 3. Next, this rule, 2 times ln of absolute value of u. You plug 3 into 2 times ln of 3 minus 2 times ln of 2. You can change it to the power form. ln of 3 square minus ln of 2 square. ln of 9 minus ln of 4. You can change it to only 1 ln. ln of 9 over 4. The next one. How can you solve this problem? How can you solve? Which method do you want to use for solving this problem? Use substitution, is it right? Use substitution, is it right? What do you think, other guys? Yes? Use substitution? Yes. Use substitution. What's you? Just say the sign. All right, sine function. du is sine prime is cosine x dx. Next, change here. So sine x is u. Cosine x dx is du. So we have it. The next, what is 0? You plug 0 into here. g of 0. You plug pi over 2 into here. We have g of pi over 2. Next, simplify. Plug 0 into here. Sine of 0 is 0. You plug pi over 2 into x. Sine pi over 2 is 1. So we can use this one. This is what? K is minus 1. K is just minus 1. So we have minus 1 over minus 1 times e to negative u from 0, 1. The same to minus 1 over e to the u from 0, 1. Plug 1 and 0. So e to the 0 is exactly 1. Change it, positive. So combine e minus 1 over e. Next, how can you solve this problem? How can you solve this problem? So do you have an idea for solving this problem? Do you have any idea for solving this problem? Integral x squared over 4 plus x cubed. So here, tangent, inverse tangent something, yeah, inverse tangent something, because you can change it, cube root of 2 and 0 here, x squared, change it, this is 2 squared plus, what is x6, x cubed squared dx. So what's like the main idea? You can use u substitution. So what is u? U is inner function x cubed. So du is x cubed prime dx. So same to du equals 3x squared dx. So we have only x squared term divided by 3. So we have 1/3 du equals x squared dx. So you can change it. This is a right g of x. So we have this one. The 2 squares here plus x cubed is just u squared. x squared dx. What's x squared dx? 1/3 du. Here, you plug 0 into this relation, g of 0. You plug cube root of 2 into here, g over cube root of 2. You plug, right? This is the whole idea. The next tip, take out 1/3. 이내가 1 over the 2 square plus u square du. So next one, was it like a g of 0? You plug 0 into here. The g of 0 is exactly 0 cube, is 0. The next one, was it like a g of cube root of 2? You plug cube root of 2 into x. The cube root of 2 cube. Cube is gone, only 2. Change it to here. So what is the answer? This is 1/3 times integral 1 over 2 square plus u square du is, you can inverse tangent. 1 over 2 inverse tangent of u over 2 from 0 to. The 1 over 6 inverse tangent of u over 2 from 0 to. The next you plug 1 over 6 inverse tangent of 2 over 2 minus 1 over 6 inverse tangent of 0 over 2. Right? So we have this result so far. So I can show it to you like this. So we have it. So next one. What is inverse tangent of 2 over 2? Do you know what is inverse tangent of 2 over 2 is? Inverse tangent of 1. Do you know what's inverse tangent of 1? Yes, pi over 4. Because we don't know this angle theta, you have to use definition. 1 equals tangent of theta. Was it like angle theta? Tangent function is 1, just pi over 4. So this is, what is inverse tangent of 0? What's inverse tangent of 0? 0. Because angle theta, same method. 0 equals tangent theta. So which angle has tangent function 0? Theta equals angle 0. So this is just 0. Simplify pi over 24. This is answer of the whole question, right? The next one. 인egral 1 over 1 plus x squared arctangent of x dx. How can you solve this problem? How can you solve this problem? Do you have any idea for solving this problem? You can use trig sub, is it right? Trig substitution. When you trig substitution, just algebraic function. We have arctangent something. Usually we don't use like trig sub. In this case, you have to use inverse 10. Yeah, u substitution is better. Yeah, inverse 10. You're right. The inverse 10. You can use u. Inverse 10. Tu is inverse 10 prime is 1 over 1 plus x squared dx. You can change it. This is like this. You can change this one to the u. 1 over 1 plus x squared dx is just du. So we have integral 1 over u du. So that's it. Like this. Adding up absolute value of u, change back, adding up arctangent of x plus c. How can you solve? Second problem. You can use, how can you solve the second problem? Yes, use substitution. U equals, what's U? You're right. Inverse sine of x du equals 1 over square root of 1 minus x squared dx. So we can change 5 to the inverse sine x times 1 over root 1 minus x squared dx. We can change integral 5 to the u, is right here. The sine, inverse sine of x is like u plus. So 1 over 1 minus x squared dx is like du. We have a simple form. Integral 5u du is 5 to the u over ln of 5, change back. 5 to the inverse sine of x over ln of 5. That's it. This is the whole idea. The last problem. So we have a general logarithmic function. What's like the best way? So in this case, you have to change this one to the, like this is better. The e square is given 1 over x times log x with the base 2 is, you can change it to the natural logarithm by using the change of base. This is same to the e square of e 1 over. This is x times ln of x over ln of 2 dx. This is same to integral from e to e square. The only reciprocal is ln of 2 over x times ln of x dx. The next one, take out coefficient ln of 2, e square 1 over x times ln of x dx. So this is like a whole idea for solving this problem. You can change it. The next thing, how can solve? How can solve this one? Integral, yeah, u substitution. What's u? What's u? Yeah, ln of x, you're right, yes. So tu is ln of x prime dx. So we have du equals 1 over x dx. The next change. You can write this is like g of x. This is like keep ln of 2 integral 1 over. So ln of x is u. What's the remaining part? 1 over x dx is just du. Next, e into here. Change g of e, g of e square. Keep ln of 2. Was it like a g of e? You plug e into here. Only ln of e. What's ln of e? What's ln of e? Do you know ln of e? What is ln of e? Do you know? Min said 1, Calvin said 1. You're right. This is 1. So what's it like g e square? Plug e square into this x. Ln of e square is, yes, 2. Cancelled, only 2. The change, 1 over u du. So we have ln of 2 times ln of absolute value of u from 1 to, you plug, keep ln of 2 times ln of 2 minus ln of 2 times ln of 1. What's ln of 1? Yes, 0. You don't need it. So ln of 2 times ln of 2 is ln of 2 squared. Right? This is the same to ln of 4. Does it make sense? So what do you think? This is right? ln over 2 squared equals ln over 4? Yeah. Don't do that. Just ln of 2 squared. This is whole idea for solving this kind of problem. So answer is like this. Yep. Okay, this is all for today's lecture. Do you have any question? Yes, you have to memorize a lot of things. So you need to memorize the differentiation formula, the integration formula, I summary, some contents in the review, chapter 6. Yes, memorize a lot. You're right. No, this is a good question. So don't change it here. This is the same. So when do you change it like this one? Only ln of 2 square. Only 2 square is yes. 2 ln of 2. You can change it. But ln 2 square, no. Don't change. So totally different. The whole ln 2 square is not 2 times ln of 2. Okay. So do you have more questions or not? Do you have more questions? So could you write any question? I will explain here. So do you have any question? No? You don't have more?